Hello. Hello everyone. Welcome to my virtual math class. I am Haruchandra Gaur from Chandannagar C. Aurobindo Vidya Mandir. This class is for class 10 and today topic the application of tangents. Chapter 15.2 in your board book. Now in 15.2 the number 3 I read the sums. AP and AQ are two tangents drawn from an external point to a circle with center O. P and Q are points of contact. If PR is a diameter, let us prove that OA parallel to RQ. Now we draw the figure. At first, we draw a circle. At first, we draw a circle whose center is at O. Whose center is at O. Now draw a circle whose center is at O. And AP and AQ are two tangents drawn from an external point A. Now draw two tangents AP and AQ. A this is the tangent A, P and AQ are two tangents at the point P and Q. P and Q are the point of contact and PR is a diameter. Diameter always passes through center of the circle. So PR is a diameter. PR is a diameter. This is the point R. This is the point O. PR is a diameter. Let us prove that OA parallel to RQ. Now join OA. OA parallel to RQ. This is the point Q. This is the point R. Given this is 15.2. This is sum number 3. Six in the life. Now, given AP and AQ, AP and AQ are two tangents through an external point A of a circle with center O. PR is a diameter. PR is a diameter of that circle. Required to prove OA is parallel to RQ. Now construction. Now we draw a line segment OQ. Now we draw a line segment OQ. Join O and O Q R O, Q R joined. O, Q R joined. Now proof of the application. Here in triangle APO, and triangle AOQ, we have, according to previous theorem, now this length of two tangents are equal and they subtend equal angle at the center. So therefore, as PA and QA are two tangents through A. PA and QA are two tangents through A. So angle, they subtend equal angle at the center. So angle POA equals to angle AOQ. Angle POA equals to angle AOQ. Let also in triangle ROQ, we have OR equals to OQ. So therefore angle ORQ equals to angle OQR, because this triangle is an isosceles triangle. An isosceles triangle, two opposite angles of the equal sides are equal, so these two angles are equal. Let angle OQR equals to theta. Let angle OQR equals to theta. So therefore this angle equals to theta. So therefore we copy this. Therefore angle ORQ equals to theta. Now this is an external angle of this triangle ROQ. This angle is an external angle of the triangle ROQ. So this angle equals to external of in a triangle. External angle equals to sum of two opposite interior angles. So therefore, angle POQ equals to angle ORQ plus angle OQR. Now POQ equals to, now angle POQ equals to angle POA, sum of these two angle POA plus angle QOA. This is equal to theta and this is equals to theta, which implies, already we proved POA equals to AOQ. POA equals to AOQ. In place of POA, we write QOA plus QOA equals to 2 theta. This equals to twice of angle QOA equal to 2 theta. 2 to cancel both sides. So which implies angle QOA equals to theta. So therefore this angle equals to theta, therefore this angle is also theta. This angle is theta. So this angle from a alternate angle, as alternate angles are equal, so OA parallel to, so therefore OA parallel to RQ. Prove. Orko Datta in comment, what is the meaning of point of contact in sum number 3? Sum number 3. Now this sum, point of contact means tangents and radius. The point of intersection of radius and tangent is called point of contact. Good morning to everybody. I wait 2 minutes for copy the application. Next question. Question number 4. Let us prove that for a quadrilateral circumscribe about a circle, the quadrilateral circumscribe about a circle, the angles subtended by any two the angle subtended by any two opposite sides at the center are the are supplementary to each other. Question number 4. Let us prove that for a quadrilateral circumscribe about a circle, the angles subtended by any two opposite sides at the centers are supplementary to each other. At first, we draw a circle. Everybody draw a circle in your copy. Draw a circle. Next, we draw a quadrilateral circumscribe a circle. Now, we draw a circle and now question number 4. This is the center O. A B C D is a quadrilateral circumscribe about circle. This is the center O. Prove that the opposite required to prove now any two opposite sides at the center are supplementary. Now AOB and COD is the point O. Given ABCD is a quadrilateral given, right? Given ABCD is a quadrilateral circumscribe about a circle with center O. Required to prove any two opposite sides subtend at the center are supplementary. Now the angle AOB plus angle COD equals to 180 degree, or angle AOC plus angle BOD equals to 180 degree. AB and CD are two opposite sides, so they subtend at the center. The angle subtend by the side AB is angle AOB, and the angle subtend at the center by the side CD is angle COD. Now AOB and COD are supplementary to each other. So supplementary means sum of their sum is 180 degree. Angle AOB, wait, angle AOB plus angle COD is 180 degree, and angle AOC plus angle BOD 180 degree. Now proof. Here this is the point of contact P, Q, R, S. Construction. Let P, Q, R and S are the point of are the points of contact of the sides AB, BD. Oh, sorry, this is the point C. Sorry. ABCD, ABCD, AOB plus COD, and AOC. Sorry, AOD plus BOC, AOD plus BOC, ABCD and AOB plus COD is 180 degree, and BOC plus AOD is 180 degree. Now PQRS are the points of contact of the sides AB, BC, CD and DA respectively. And join OP, OQ, OR and OS are joined. This is the point O. OP, OQ, OR and OS are joined. Proof. Now proof. Angle BOP equals to angle BOQ. Now angle AOB plus now angle AOB plus angle COD, sum of two opposite angles. We have to show sum of these two angles equals to 180 degree. Now AOB plus angle COD. Now AOB equals to angle AOP plus angle BOP plus, and angle COD equals to angle DOR plus angle ROC. Now AOP equals to, now AP and AS are two tangents, so AOP equals to angle AOS. So write AOS AOS plus, and BOP equals to, right, BOQ plus angle DOR. DS and DR are two tangents, so this angle equals to this angle. So DOR equals to, right, DOS plus angle ROC this angle, RC and CQ are two tangents, so this angle equal to this angle, ROC equals to angle COQ. Write the logic. Two tangents passing through a common point, they subtend equal angles at the center. Now AOS plus angle DOS, right? AOS plus DOS. Rearrange the term, plus angle BOQ plus angle COQ. Now from the figure we see that angle AOS plus angle DOS, AOS plus DOS, this is angle AOD, AOD plus BOQ plus COQ, this is equals to angle BOC. Now AOB plus COD equals to angle AOD plus BOC. We know the angles about a point, the sum of all angles about a point is 360 degree. So now angle AOB plus angle BOC plus angle COD plus angle AOD is equals to 360 degree. The sum of all angles about a point is 360 degree, which implies now AOB plus COD equals to AOD plus BOC, and angle AOB plus angle COD plus angle, rearrange the term, angle BOC AOD plus angle BOC is equal to 360 degree. Which implies angle AOB plus angle COD, and AOD plus BOC equals to, prove AOB plus COD, AOB plus COD is equal to 360 degree. Now twice of angle AOB plus angle COD is equal to 360 degree, which implies angle AOB plus angle COD is equal to 360 divided by 2, this is 180 degree. So proved and see. And sum of four angles is 360 degree and sum of two angles is 180 degree. So therefore sum of other two angles 360 minus 180, this is 180 degree, and therefore angle BOC plus angle AOD, other two angles BOC plus AOD, this is equal to 360 minus 180, this is equal to 180 degree. Proved. Now copy from the board, comment section. Sir, if we take angles SDO and DOR in place of SOD and DOR, no, no, SDO. No, this is not SDO. SOD and SDO, these two angles are not equal. No, angle SDO and SOD are two angles are not equal. Now we copy this. হ্যাঁ বলো, হ্যাঁ বলো বলো। ঠিক আছে, আমার 11:30 ক্লাস চলছে এখন। না, আমার তো লাইভ ক্লাস চলছে। আচ্ছা ঠিক আছে। Next question, question number 5. I read the question. Let us prove that, question number 5, and you see the question in the screen. Let us prove that a parallelogram circumscribed by a circle is a rhombus. Let us prove that a parallelogram circumscribed by a circle is a rhombus. Now we draw a circle and also draw a parallelogram circumscribed about a circle. First we draw a circle. Next we draw a circumscribed parallelogram. Circumscribed parallelogram. In a parallelogram, the opposite sides are parallel. So we draw two parallel lines. Just touches the circle. Now this is the figure of A, B, C, D is a circumscribed parallelogram of the circle. Its center is at O. given this is number network is very poor. Question number 5. Question number 5. Given A B C D is a circumscribed circumscribed parallelogram about a circle with center center is at O. Network is very poor. A circumscribed parallelogram ABCD is a circumscribed. This application is the last. Today, this application is the last application, and the remaining application of that chapter are homework. ABCD is a circumscribed parallelogram about a circle with center O, and with center is at O. Required to prove ABCD is a parallelogram given. Required to prove ABCD is a rhombus. ABCD is a rhombus. When a parallelogram is a rhombus? When a parallelogram is a rhombus? Now, if in a parallelogram, two adjacent sides are length of two adjacent sides are equal, then the parallelogram is a rhombus. So here we proved AB and AD are adjacent sides, AD and CD are adjacent sides, and BC and CD are also adjacent sides. If AB equals to AD, or AD equals to DC, or DC equals to BC, or BC equals to AB, then the parallelogram ABCD is a rhombus. Proof. Now ABCD is a parallelogram. So in a parallelogram, pair of two opposite sides are equal. So AD equals to BC and AB equals to DC. In a parallelogram, pair of two opposite sides are equal. Now AB, now this is the point of contact. P, Q, R, S. Let P, Q, R, S are the point of contact of the side AB, BC, CD and DA respectively. So therefore AP equals to AS, DS equals to DR. The length of two tangents passing through an external point are equal. So AP and AS are two tangents passing through an external point A. So length of two tangents AP and AS are equal. DS and DR are two tangents passing through an external point D. So DS and DR are equal. CQ equals to CR. BQ equals to BP. Now you prove AB equals to BC, Now AB plus CD. Now AB plus CD. AB plus CD. Now AB equals to AP plus PB and CD equals to DR plus RC. Now AP equals to prove AS, PB equals to BQ plus DR equals to DS, RC equals to CQ. Now AS plus DS, BQ plus CQ. Now AS plus DS equals to AD, and BQ plus CQ equals to BC. So therefore AB and CD are equal. AB and CD are opposite sides of a parallelogram. So AB equals to BC. So now AB and CD equals to, right, AB equals to AD. AD equals to BC. BC plus BC, which implies twice of AB is equal to twice of BC, which implies AB equals to BC. In a parallelogram, two adjacent sides are equal. So therefore, ABCD is a rhombus. We copy this, and other application and MCQ question and short answer type question of this chapter, that is chapter 15.2, are homework. The network is very poor, sir, very network constantly freezing. Okay, I stop my live streaming.